I started going, I'm sorry, and I forgot to record. So we just did the top part. We haven't done any examples yet, so we're just talking about polynomial functions. Here's the homework assignment. We said polynomial functions are like x, x squared, x to the thirds, x to the fourth. Non-polynomial functions are these guys, okay? We talked about the degree, the leading coefficient, and the constant term for each one of those polynomials. If you need to pause this to go back to the homework assignment and all that stuff, you can do that as well. And then we said linear functions, quadratic functions, cubic functions. Like here's a linear function, but it could also look like this with numbers in there. X squared is a quadratic function, but also numbers in there. X to the third power, but also numbers in there would be cubic functions. X to the fourth power, but also numbers in there would be quartic functions. Okay? I'm going to get rid of all my bubbles, okay, to make him less messy. All right? Okay, so now on to example 1. This is long division. Whew! Okay? All right. Long division. Do you guys remember this from Algebra 2?
Yes.
Yes, kind of. You remember that you hated it, right?
Yeah.
Yeah? You do? You remember that you hated it? Okay. Long division, when you were doing stuff like in elementary school, they had you do long division. They would say like, let's say 1,763 divided by 2. Okay, this is long division. This is like without using a calculator. Okay? So you say, what does 2, nope, what does 2, or does 2 go into 1? No. Does 2 go into 17? How many times? 8 times, and that would be 16, and then you subtract the 16 and you drop the 1 down, right? And then you drop the 6 down again, and then coincidentally that's another 8. 8 times 2 is 16, subtract, that's 0, and you drop the 3 down. Okay? 2 goes into 3 once, subtract the 2, and there's 1 left over. So you write it as a remainder of 1 over 2, right? Okay? I did that for a reason. I wanted to make sure it had a remainder for a reason, okay? So this is how you write that. We're doing the same thing, but we just have x's involved, okay? It is exactly the same process, though. Exactly the same process, okay? So following along those same rules, what we're going to do is we're going to write our inside on the inside and our outside on the outside. So x minus 2 goes on the outside. Now, this is the very, very most important thing to do when you are doing long division, because if you don't start it out the right way, you will screw it up and get the wrong answer. 3x to the fourth power is my highest, but this is the very most important thing. He does not have an x to the third power. So we put plus 0x to the third power. You have to have a placeholder there. Wow. Otherwise, it screws everything up and your answer is wrong. Because you'll run into problems when you multiply it back through. Okay? So, plus 0x to the third power, he needs to have that in there. Okay? X squareds minus 8x squared minus 11x plus 1. Those all go in order after that. So I need to make sure I have everything in order starting with the first one. I have a fourth power, a third power, a second power, a first power, and then a constant term. Okay? All right, so we are ready to long divide. Are we ready?
No.
We have to insert that in there if there is not an x to the third power. We just put 0 in front of it. So it holds the place. It holds the place. Okay? All right, very first thing that we asked up here, we said how many times does 2 go into 17, right? Yeah. So how many times does x go into 3x to the fourth power? Or what do I have to take times x to get 3x to the fourth power? 3x to the third, right? That's what I have to multiply him by. I don't care about the 2 right now, okay? We only care about the x, okay? So now the next thing that we do is multiply it back through. So 3x to the third power times x is 3x to the fourth power, like it should be, right? But now I care about the 2. Now I multiply him by negative 2 as well. So 3x to the third power times negative 2 is negative 6x to the third power. Yeah? Okay? We write it right below. Now, take a look at this. If we would not have written an x to the third power, we would be having an x to the second power overlap with an x to the third power. Does that make sense? That's why I have to put the x to the third power in that column. Otherwise, I would end up with problems. Okay? Now, look what we did up here. After we wrote the 16, what did we do? We subtracted it, right? So what we have to do is the very next thing, I'm going to do this in a different color. I have to take and switch the sign of all of the things that I wrote down, okay? So instead of this being 3x to the fourth power, it's going to be a negative. And then this guy is going to be plus 6x cubed. We have to change the sign of everything that's there. All right? And then I add them together, top and bottom, and I write down my next thing. So 3x to the 4th power minus 3x to the 4th, that should cancel out. Okay? What is 0x cubed plus 6x cubed? 6x cubed, and then I drop 1 down, just like we did on when we were dividing by 2. Okay? So there he is. All right? And then I repeat my process all over again. Okay? So what do I have to take times x to get 6x to the 3rd power? 6x to the 2nd power, right? Okay? Now I distribute it through, so I multiply the 6x to the 2nd power over here. 6x squared times x is 6x to the 3rd power. And 6x squared times negative 2? Negative 12x squared. And then we have to flip the signs, right? Because you have to do that. You always have to flip the sign. Okay? So the x to the 3rd powers are going to cancel out. Negative 8x squared plus 12x squared is 4x squared. And then drop down the negative 11x. Okay? All right? So then I start over again. I repeat the process again. So what do you have to take times x to get 4x squared?
4x.
No.
4x.
4x, right? We're dividing. We're not subtracting. It's not 3x, it's 4x, right? Now, what is 4x times x? 4x squared. Okay, what's 4x times negative 2? Negative 8x. And then I flip the sign. Minus, plus. Okay? The x squareds are going to cancel off. So, negative 3x plus 1. We're getting close. You have to have a lot of room, which we don't have a lot of. So you have to kind of write small. Okay? Now we're ready to go again. Okay, one more time. What do you have to take times x to get negative 3x? Negative 3. Negative 3 times x is negative 3x. Negative 3 times negative 2 is positive 6. Okay? And then we flip the sign. So negative 3x and positive 3x go away. Positive 1 and negative 6 become negative 5. Because it was negative 3 times negative 2. And it was a positive 6. Right? So now it's a negative when we flip the sign. Okay? Now, what do you have to take times x to get negative 5? You can't. Right? This is my remainder. Okay? Now, there are 2 ways of writing this. Okay, watch this and you can decide which way you want. Okay, it is a negative 5 as my remainder. So what I can do is I can write this as plus negative 5. Don't write this down yet. Plus negative 5 over x minus 2, right? Or I could do minus 5 over x plus x minus 2. Does that make sense? Because it's a negative 5. Which way would you like to write it?
Negative.
You would just like to do minus 5? Okay, so leave it like this. That's fine. Okay, so you would always just do either plus whatever, or if it's already a negative, you could do minus whatever. Okay, this is my solution when I divide him. Woo, that was really long and ugly. Yucky, yucky. Okay. Yeah, there'll probably be some longer ones like that. Okay, just take your time and go through it. Take your time. Use different colors if you need to. That helps me a lot.
Yeah, that helps.
Okay, that helps a lot. Okay. All right, we'll do a synthetic divide one. That's this guy over here. You will like synthetic division a lot better.
What's the difference?
Okay, you'll see. The difference is how you set it up. Okay, so long division and synthetic division. Okay, are we ready to move on to synthetic division? Yeah? Synthetic division. Okay, we are taking this guy and we are dividing by x plus 3. Okay? Synthetic division, the reason why people like it is because it does not involve x's at all. You are just stripping the x's away and looking at the numbers. Okay? So, the first thing that you need to do in your synthetic dividing is take x plus 3, what you're dividing by, and set it equal to 0. Okay? If we set x plus 3 equal to 0, and we solve for x by subtracting that 3 over, x will be equal to negative 3. So, the number, after I strip the x away, the number that I'm going to be using is negative 3. Okay? your synthetic division box is going to be set up the opposite direction. It's going to look like this, and we're going to put negative 3 off to the side over here.
Oh, yeah.
Okay? So your box goes the opposite direction. You need a bigger box, yep. Okay? Because we're going to have 2 rows inside of that box. Okay? We're going to have a number here and a number here, a number here, a number here, a number here. Don't write that down. But anyway, we're going to have two rows for the box. Okay? Now, the numbers that go inside of the box are determined by what I'm dividing by. Okay? So, I start with the x to the 5th power. What number's in front of x to the 5th power? 1. So I start writing a 1 down here. Okay? Then I leave a little space, and the next number I write is 5. The next number I write is 6. Now, do we need to put a 0 in anywhere? Like we did on the last one? Do we need a placeholder anywhere?
No.
Because we have a 5th power, a 4th power, a 3rd power, a 2nd power, 1st power, and a number, right? So we're good. Okay? All right, after the 6 comes
Negative
1.
one.
After the negative 1 is
4.
4, and after the 4 is 29. Okay? There we go. We're ready. Whoop. 29. I'm gonna make my box just a little bit longer. Okay? So make those spaced out enough so that you don't they don't look like they're running together like 156, right? They're individual numbers. Layla would say leave a finger space. You don't necessarily have to have an entire finger, maybe a pinky space. I don't know. But a finger space. They're learning that in kindergarten. Okay? All right, very first thing after I have him set up and ready to go is the easy one. You drop the 1 down. Boop, that's it. The very first number just gets dropped down. Okay? And then we take negative 3 times 1, and I put it right in this spot. Negative 3 times 1 is negative 3. Okay? Then I add those guys. 5 plus negative 3 is 2. Okay? Then I multiply again. So negative 3 times 2 is negative 6.
0.
Then I add those guys. And it is 0. And then I multiply again. Okay? Let's go. Do we need to go a little slower?
Yeah.
Okay? A little slower. So, what we have right now, we have to start with the 1. Then I multiply these together. Negative 3 times 1, and it goes in this spot. So I'm multiplying those guys. Then I add these 2. 5 and negative 3 becomes 2. Then I multiply those guys to give me negative 6. Then I add those guys to give me 0. Now I multiply. So it's multiply, add, multiply, add, multiply, add, multiply, add until I'm all the way to the end. Okay? So I'm at 0. Now I'm going to take negative 3 times 0, which is 0. And then I add. Okay? Negative 1 plus 0 is negative 1. Then I multiply.
Wait, what did you multiply that equals 0? 3 times 0?
Yep. 3 times 0 is 0. Negative 3 times negative 1 is a positive 3. Then I add. 4 plus 3 is 7. Then I multiply. Negative 21. Then I add. 29 plus a negative 21 is 8. And I put a box around 8. He is my remainder. Okay? I always put a box around the last one because that's my remainder. Okay? No, he's the remainder just because he's the last number. The last number will always be your remainder. Yes. Okay? All right, now I have to put the x's back in there. Okay? All right, I'm putting the x's back in there. I started with x to the 5th power was the highest power. And I was dividing by x. So what power will my first term be? X to the 4th, right? 5 divided by, dividing an x out would be x to the 4th. So this guy is going to be my x to the 4th power. This guy is my x to the 3rd power. And I just keep going down from there. This guy's an x to the 2nd power. This guy's an x to the 1st power. And this guy's just my number. Okay? And we're going to build him back. Okay? Does that make sense how we get that?
Why do you put it down? Like, why is it x to the 4th times? Because you're dividing by the x.
So yeah, because if you would take an x to the 5th and you would divide by x, this would be just x to the 4th power. Does that make sense? So you start with x to the 4th power. Okay, so let's build him back. We have 1x to the 4th power. Okay, then what? Plus 2x to the 3rd power. You see this? Plus 0x to the 2nd power. Minus 1x to the 1st power. Plus 7. Plus 8 over. What were we dividing by? X plus 3.
Yeah.
Okay, so that's what he will look like. All right, now, that's a lot of stuff that I don't necessarily need. Like, I don't necessarily need the 1 here. I can just write him as x to the 4th power. I don't necessarily need the 0x squared, and I don't necessarily need this 1. So I'm going to write him like this. X to the 4th plus 2x cubed minus x plus 7 plus 8 over x plus 3. You can leave him the way that we just did up above there. I don't care. But if you get rid of all the unnecessary things, you can just write him like that. Okay? Does that make sense?
Will we always get to use
Okay, that's my next point. Okay, because 0x squared isn't doing anything. Like 0 isn't doing anything. So you can always get rid of the zeros if he's there. Okay? Good question. All right. Now, why not use synthetic division always? Because it's easier, right? We like synthetic division better. Why not use synthetic division all the time? Here is why. On this last problem, we were taking this guy and we were dividing by x minus 2. We could have done that problem using long division, okay? Or, using synthetic division. But let me give you an example over here of when you cannot, okay? Let's say I'm taking 3x cubed plus 7x squared minus x plus 8, and I am dividing by x squared minus 3x plus 4. This problem, I have to use long division, okay? Because remember in synthetic division, the first thing that I do is set this guy equal to 0. I can't solve that guy unless I factor him down or whatever, right? Okay? So you can only use synthetic division when you are dividing by linear factors. This is a quadratic. I'm dividing by x squared. So I cannot use synthetic division when I'm dividing by big long things. I have to use long division. Does that make sense? Okay? Long division you have to use when it's really ugly. Okay? Synthetic division you can use if you're dividing by nice factors like x plus 3, etc. Okay? One more thing that I want to add. In long division, do you remember we got to a point where we write the thing down and then we have to flip the sign, right? Write the thing down, flip the sign. Write the thing down, flip the sign, right? You remember flipping the sign? Why don't we do that in synthetic division? Synthetic division, we never flip the sign, right? When we set this guy, this x plus 3 equal to 0, and we made it negative 3, that flipped the sign the whole way through by just doing it that once. Does that make sense? Okay? So we don't have to flip the sign, flip the sign, flip the sign, flip the sign everywhere throughout the process. We just flip it that one spot, and then he's good to go. Because he is left with the x's inside of there. Right? And long division, we have to leave the x's inside of there. So it kind of makes it gross. Yeah. Okay? So that's just the way that works. Okay? Let's stop. Okay? Let's stop. I was going to do example 3, but let's stop. Okay? Long division, synthetic division. They're starting us off in chapter 4. Like, usually they kind of ease you into it. Chapter 4 is like, nope, let's give you the hardest stuff possible to start with. They really did. They really threw you into the pit. Okay? You might be able to do the first couple problems if you wanted to start, but it's not going to be due tomorrow. So, all right, everybody say bye, Maddie.
Bye, Maddie.